Hello, let's go over the questions in exercise 1G. So given the fifth term, 10th term, find the 15th term, we can first find out what the common ratio will be by dividing the 10th term by the fifth term. And that will give us 5 times the common ratio, in this case r to the power of 5. So this will give us the ratio here. So I'm going to be taking the nth root. In this case, I want the fifth root. So that's 1.5. Now the easy way is to take one of the terms. So for example, if I start from the 10th term, all I got to do is to multiply this by r to the power of 5. So do you see how if we use the 10th term, we don't even need to know what r is, because we could actually just take the ratio. So you could also just do u10 times this here, because this represents r to the power of 5. But you could just take the radius, not the radius, the ratio, raise it to the power of 5, and then multiply by the 10th term, which is this here. So that will be our answer. So if I write down 303.75 times this, so I'll give my answers to two decimal places. And if you were to do it this way, you will see that you get the same answer, just for this specific question. See? All right, so second question. So very similar to the first, but this time we already know what the common ratio is. So we can use that fact to generate what the 20th term is. If we start from the 6th term, then I would need to multiply r by 40 repeated times, plug in what I have, and then just put in the GDC. Make sure you do the negative key, otherwise it will return an error. Negative 56.29. So again, I'll just leave it as two decimal place. All right, so we have the first three terms in a geometric sequence. Find the possible values of x. So what we can do is to set up the ratio. If I do the second term divided by the first term, that will have the same ratio as the third term divided by the second. So we can use our cross multiplication shortcut to get rid of the denominator. Now I could actually expand the left-hand side and then set it equal to 0, either using factorization or completing the square or the quadratic formula. You will be able to find what x has to be. But here's an easier way. Because this is a perfect square, I can just undo the square by taking the square root of the right but also considering the negative solution. So it's plus minus the square root of 16. This is very useful because it saves us a lot of time, which is plus minus 4. And then I can just move 2 to the other side and read this as minus 2 plus 4 or minus 2 minus 4. So we separate this into two cases to give us the two answers that we want. So we first take plus and then followed by minus. So that's how you can read plus minus cases. And to be sure, you can plug it in your calculator and see if they actually give you a geometric sequence. What I mean is actually plug x back into the sequence. So if x is 2, then this will be 4 and 1. And then as you can tell, this is a common ratio of 1/4. And if I were to plug in x equals -6, I will have 16 and -4 and +1. So this second sequence is by multiplying -1/4. So that in turn is also a possible geometric sequence. So we're good. Find the number of terms in this sequence. So very similar to arithmetic sequence, we can sort of take the last term and do something with the first term in order to figure out how many numbers are there altogether. So you can set it up as follows. You can do the last term divided by the first term. And then that will give us a number, but we were trying to find how many terms there are, right? If I take the last term and divide it by the very first term, I should have n minus times the common ratio. Now, because I haven't taught you a logarithm yet, this could be a little bit annoying. So the ratio here, we know that this will be times 2, just by observing the sequence. So we can write this as 2 to the power of n minus 1, and we have so this should be 256. So in class, I taught you how we can do repeated division to figure out what that is in terms of power of 2. So we can always just do that if we don't have a calculator. So if we count this carefully, that's 1, 2, 3, 4, 5, 6, 7, 8. So that means this could be expressed as 2 to the power of 8 equals 2 to the power of n minus 1. And then if I set the powers equals, then I have 8 equals n minus 1. So therefore, there will be 9 terms. Now later, when you later, when you learn logarithm, what you can do is you can take log 256, and then you can divide by log 2. This tells you the power that's needed. So you don't have to do the long division. So notice that the 8 is going to give us how many times you can repeatedly divide 256 before it turns to 1. So this is a nice quick way to figure out what 2 as a power of 2, what 256 is as a power of 2. So you could figure this step out quite easily by doing log 256 divided by log 2. Okay, pretty neat, huh? Find the possible values of the common ratio of a geometric sequence whose first term is 2, fifth term is 32. So now we can approach it very similar to what we did in the first question. Here, if I take the difference, if I take the ratio between the fifth and the first term, I should get 4 times the common ratio. When I say 4 times, I mean like r to the power 4, because it's like r times 4r times r times r many times. So it should be r to the power 4 representing that ratio. So you're thinking of number that multiplies itself 4 factors many times to give you 16. So it's either 1 times 1 times 1 times 1, or 2 times 2 times 2 times 2. But, because this is an even power, you can also have negative as a possible solution. So this will have a common ratio of either positive or negative 2. And we're done. So in the year 2017, we have 232 students. And in the year 2027, we want to see how many students are there. So every year it grows by 3%. But as a multiplying constant, we actually are multiplying 1.03. The 1 represents the original amount, and then that 0.03 represents the extra amount. So by combining them, I will have 1.03 times as much as the previous year. So you should be able to see that this is a 10-year gap. So fast forward 10 years. So in other words, you want to do this 10 times. So we can write the population being, or just number of students, equals 232 times 1.03 to the power of 10. And what does that give us? $311.7886. So I will round this either up or down. But as long as this should be an integer. Okay, make sure this is an integer, because you cannot have a fraction of a person. Okay, we don't want any missing limbs or any parts of a body. Okay, we want a whole student. So this comes in 2 parts. This is actually a famous tale. This is an Indian, I think, court tale about how one of the tacticians were asking the king to give him a grain of rice on the first day, the second on the second, and doubling that every day, and I think for a month or something. But essentially, the king actually ran out of rice pretty soon, because he didn't recognize that this was such a huge change. This is a huge sequence when he's actually doubling every single day. It seems like it was a very little at the beginning, but after 20 or so days, it goes up quite quickly. I mean, it's doubling. You're like doubling into the millions and billions. Okay, so first day is 1 grain. So basically, you're looking at 1, 2, 4, 8, 16, and so forth. So that means on the 30th day, so you start off with 1. That means I want u sub 30. Start off as 1 times 2 to the power of 29. Okay, not 30, because it's n minus 1. So this will be 2 to the power of 29. Is that going to fit my calculator? Oh, okay. So how big is this? So if I put some commas in, you will see that this is 536 million. Rounds up to 537. Man, that's a lot of rice. How many grains of rice are there in the bag, I wonder? Now, which square would contain exactly 512 grains of rice? So basically, it's asking you which day, and because you're filling the grains of rice on the chessboard. So you can just write down the n-term formula, which is 1 times 2 to the power of n minus 1. And we want to set u sub n equals to 512. So just like the problem we had earlier, we want to change 512 in terms of power of 2. But now, you know the tricky little thing. We can just do log 512 divided by log 2 to immediately give us what that power is. So now if I just equate the power, I get 9 equals n minus 1. So therefore, it's going to be on the 10th square. So if your parents is asking you to do chores at home, you can ask them, hey, I will do the chore if you give me only 1 cent on the first day. And then can you give me 2 cents on the second, 4 cents on the third, doubling every day for 1 month, just 1 month? Because after 1 month, actually after, on the 30th day, you will be getting this many pennies on that single 1 day. So this is 536 million cents, which if you divide by 100 will be $5.3 billion. Okay, so please convince your parents to do that and share me your wealth. Okay, because I taught you that. All right, and we have our last question. So we have the first and the fifth term, and we want to find out what the second, third, and fourth term could be. So there are actually 2 solutions. But let's just carry the procedure normally. We take the fifth divided by the first, and that will give us r to the power of 4, because it's 5 minus 1. So that is 16. We have seen 16 before. So this will be plus minus of the fourth root of 16, which is 2. So we take each case separately. If r equals positive 2, then we have u2 equals 16. So I just multiply 8 by 2, and then multiply this by 2, and multiply this by 2. And if r is negative 2, we multiply 8 by negative 2, and second term by negative 2 becomes a positive still. Multiply negative 2 becomes a negative. So very similar, except one of them stays positive throughout, and the other goes in between positive, negative, positive, negative. All right, and that's the end.